Welcome to the AWS Solution Architect Associate Level, lesson number 1, AWS Overview. What you will learn. By the end of this lesson, you will be able to understand an overview and the key features of AWS, trace the history of AWS itself, explain the global distribution infrastructure of AWS, understand how AWS became the market leader as they currently are, as well as discuss each AWS product and service. Let's start with the overview then. So, Amazon Web Services, also known as AWS, and in fact I might actually refer this to AWS more often because it's shorter and it's easier to actually pronounce, is a secure cloud service platform. It offers cloud-based infrastructure for compute, database storage, content delivery, and other functionality to help business grow and scale. You can run a hybrid application across on-prem and cloud services using AWS Features and services. It has pay-as-you-go pricing model, which is the biggest advantage compared to the existing IT infrastructure. You pay for what you use from AWS. If I can actually pause here for a second and explain how it works. In a normal data center, you basically buy a server, put it into the rack, and provide power, provide internet, and basically the cost of this is a cost of the box that you had to purchase in the first place. Then you have a price of the software on top of that. You have a price of a networking, power, cooling, and all of those features. Despite the fact it might be in data center or it might be in on-prem or in your office, you always have certain costs involved. Pay-as-you-go is actually totally different. You basically pay for 1 hour of resources that you buy from AWS. You can spin up a very small server, you can spin up a very big one, but you only pay per hour. That means if you stop the server, you don't pay for it, hence the pay-as-you-go model. The vast array of AWS products and services allows you to build sophisticated applications with increased flexibility, scalability, and reliability. Security is better than other. The security in the cloud is much better than in the on-premise. AWS provides security certifications and accreditation, data encryption capabilities, as well as they have exceptional hardware security. I can tell you right now that AWS itself has been such a secure platform. It's been pretty much built from ground up as a security that currently they're also providing something called GovCloud, which is available in the US, and that allows US government to host big subsets of their government information on the AWS itself. It's got multiple ISO certifications, security-wise, and it's been actually ranked as #1 security cloud provider by Gartner in 2015 and 16. Which is pretty impressive, and honestly, it's amazing. History and evolution of AWS. In this section, we'll discuss how history of AWS and how it's evolved to the current state. So let's follow the timeline. So, in 2003, let me maybe make this a little bit smaller because I went a little bit overboard with that. Trigger happy. In 2003, visions for AWS is presented to AWS.com in form of a paper by Chris Pinkham and Benjamin Black. Those two guys went to Amazon.com, which is the biggest online retail store, and presented a paper that allowed Amazon to use specific services back in 2003. In 2004, AWS released the first public service called Simple Queue Service. In 2006, AWS officially was launched to a public market. In 2007, over 180,000 developers signed up for AWS. In 2010, Amazon.com retail web services were moved to AWS, As from 2010, actually, every single resource from Amazon.com, as well as any other local country, is actually hosted on a subset of Amazon on AWS platform itself, which is pretty impressive. In 2012, the first reInvent conference was held, which is now a yearly event. If you're going to ask what reInvent is, I can tell you it's extremely awesome event that AWS is hosting every year. The biggest one is in Las Vegas, and it actually happened around 2 weeks ago now. Actually, last week happened. It lasts for a few days. It's pretty much comparable to a Apple keynote that is famous around the world, and a reInvent is the biggest event like this pretty much on the whole planet regarding the cloud computing itself. In 2013, AWS certification was released, and they started with a batch of small 3 certifications, SysOps, DevOps, and Cloud Architect. In 2015, for the first time in the history of AWS, AWS actually became profitable as a platform itself, and it made $2.1 billion in a quarter up until Q3 of 2015. Now, global distribution. AWS has a global distribution, and the regions are let me just okay. A region is a geographical area isolated from AWS regions to provide the highest possible fault tolerance. There are currently 13 geographical regions, of which quite a few are in the US. There are 2 regions in Europe, one in Ireland and one in Frankfurt, and the one is coming in UK quite likely January, February 2017. There is a single region in São Paulo. There are quite few regions in Asia as well. So total number is 13. Each region consists of availability zones, and there are 35 of them as we currently speak. They are present in the US, they are present in Europe, as well as they're present in Asia, as well as São Paulo in South Africa. Each region consists of availability zones. We call them AZs, and each of those zones is basically, you can think of it as pretty much a data center. Each single region itself consists of multiple data centers. So if we, for example, look at North Virginia here, the number is 5. That means that we have a 5 physical data center in close proximity that work together to be able to provide almost 100% uptime. A downtime of a single data center doesn't mean that the whole region goes down. In fact, it's not. So there are different numbers of AZs per region, and you can actually view this on this particular chart, as well as you can read more on AWS itself. All of the AZs, so availability zones, are connected between each other via this super low latency fiber links, and this is what makes them so unique. If you distribute your, for example, application in a region, you can use multiple AZs, and in this case, if one goes actually down for any particular reason, there's maybe a fault, or there's a power cut, or some sort of network issue, your application is still up and running very, very happy in other AZs because it's a fully redundant solution. So there is not a single point of failure. As I mentioned before, a region is a geographical area isolated from other Amazon regions to provide greatest possible fault tolerance. AZs located within a region with at least 2 per region are connected via the low latency links, and you can see more or less how it works. What's worth remembering, and you might have this question on the exam, is basically that there are always minimum 2 of availability zones per region. And that's a key design of AWS, not to have a single point of failure. Now, edge locations. Edge locations are located in most of the major cities around the world to distribute the content to the end user with reduced latency. What it means is that, for example, if your application is hosted in Dublin or in US, and your client actually is accessing the application maybe from India or from China or from anywhere in the world you think, they actually do not connect, or they don't have to connect directly across the whole world. In fact, they can connect directly from the nearest location to them, and that's the edge location, which means that edge location and the source of your application is connected via extremely quick fiber connection, which makes it extremely quick to load. There are multiple AWS products that AWS is offering, and they have a compute, storage, database, analytics, applications, and development services. Those will help you and organization with a better speed, lower IT costs, and scale applications. And they're basically divided into these small sections to better understand how they actually connected. So you have a compute one, and then you have basically resources underneath. You have a storage one, which actually has the services regarding different things like S3, CloudFront, and others. You have a developer, you have a databases, you have a networking, and pretty much every other is pretty much divided into this section. And all of those have the unique kind of logos, as well as they have unique name. So as we go along, you will be able to actually understand much more, and you understand what all of those are for. So as I said before, AWS was named by Gartner, which is actually #1 review for all the technology in the world, as the #1 cloud infrastructure provider. You can see AWS is actually leading the whole pool. It's not only a leader, but also it technically and price efficient and security wise, all of this combined together made it extremely agile and great. Hence, actually, is on top of the board. Just behind of that, there's a Microsoft, which is a leader as well, obviously with their Azure platform, and we have a bunch of other guys that are trying to catch up, but they're nowhere near that particular AWS itself. Hence, doing the certification to AWS will quite likely allow you to open yourself to organizations worldwide that pretty much everyone is using nowadays. And if they're not, quite likely in the next 2 to 3 years, everyone will be on the platform, on the AWS itself and on the cloud itself. So I can assure you that it's amazing. Great. So what I will do, I will actually go through the quiz itself, and we'll basically answer this all together. So what I'm going to do is I'm going to read the question, and if everyone can actually type their answer in the question and answer box, that would be absolutely great. I can see already people answering the question, which is great. How many geographical regions AWS has? A10, B13, C33, D190. I can see 13, 13, 13, 13, 13, pretty much everyone. The correct answer is B, 13. That's correct. 13 geographical regions, 35 AZs, and it's available in 190 countries. Great job, guys. That's absolutely great. Next question is, what is the minimum number of AZs, also known as availability zones, within a region? Answer A, 5. Answer B, 33. Answer C, 3. Answer D, 2. Okay, I can see the answers. Okay, so I see the correct answer is D, number 2. I can see that few people, well, majority of you answered D, which is great. I see also that Ashok and Charajit answered 3 and also 33. I'm going to explain that that's the wrong answer, but I'm going to explain why. Minimum amount of AZs, also known as availability zones, is 2. The reason for it is, in order to be fully redundant, not to have a single point of failure or presence, you need at least 2 points, and AWS provides at least 2 AZs in every single region to make sure that your application or whatever you're deploying there is fully available in case something goes wrong with one of the data centers. 2 is absolute minimum. However, if the data center provides more, feel free to go for even more to be able to achieve even greater uptime. So the correct answer is 2D. I can see the charges is saying as per AWS site, latest is 40 AZs and 15 geo regions. That's correct. However, the certification itself is still not updated, and AWS itself didn't update their own questions yet because they introduced those AZs not that long ago, and up until they release the latest batch, we're still working with exactly what we have here, and it's still extremely valid, and it will be for next 2 years. So we don't really know when AWS will actually change their questions in the future. It takes them some time to do that, but for the purpose of this particular course and certification, the answers and numbers here are pretty much correct. But yes, Charajit, you're absolutely right about that, and they recently introduced that. Let's skip to another question. Which AWS product uses edge locations to provide CDN service? AWS EC2, AWS Web Services, Amazon CloudFront, or none of the above? That's pretty much great. So, majority of you answered C, which is the correct answer. That's absolutely correct. I can see a few people answered D, none of the above, and also one person answered AWS. Now, the correct answer is CloudFront. The edge locations, whenever you hear edge locations, it's always CloudFront. The reason for it is it's available in over 190 countries, and pretty much that's the service. We'll talk about it more in the future as discussing what it's actually used for and how it's used for. So the correct answer is C, Amazon CloudFront. Next question. Oh, that's actually the end of the questions. I would say great, guys. So far, pretty much solid. No worries if you answered wrong. We are here to learn, and that's exactly what we're trying to achieve. I'm pretty sure you're gonna hear this question next time. You're gonna answer correctly. So great job. Let's go further. So, overview of AWS products and services. In this section, we will get an overview of all the products and services that AWS platform has to offer. So, let's start with compute section, which is exactly here. So, what is compute? The Elastic Compute Cloud, which also is known as the EC2 from Amazon, provides resizable compute capacity in the cloud, which is intended to make web-scale computing easier for developers. Users maintain complete control of their computing resources. Amazon operates under a pay-as-you-go model, as I actually mentioned before. It also takes minutes to obtain and boot new server instances, so it allows you for quick scaling and actually compute requirements change. So that's EC2. In fact, you're gonna hear EC2 quite a lot, and every single system that you ever will build will always consist of EC2. And EC2, if you think about it, what it is, it's basically a server. It's a server. It's an instance. We also call it an instance because you only need the server for specific task. For example, you need to have a web server, and a web server consists, let's say, of a server itself, so where the application is running, and you have a database. So what you will need for that is a one EC2 instance, so in this particular case server, that you will be able to spin up or launch or boot, as we also call it, and that will provide you the computing capacity, which you can put OS on top, and you can have any application you want to actually host. In this case, obviously, we mentioned a web server, and that's pretty much what AWS EC2 is. Also, AWS provides a service also known as EC2 Container Service, also known as ECS. What it is, it's a highly scalable, high-performance container management service that supports Docker containers and allows you to easily run applications on managed clusters of AWS EC2 instances. It's worth mentioning that it's not featured in the Solutions Architect Associate exam. It's mainly for your knowledge at the moment, but it's not gonna be during the exam itself. I have a question here from Charanjit. As AWS Solution Architect, do one has to deal with all the features of AWS? It's a very good question. The short answer is no. The longer you work with AWS, quite likely you need to be exposed to more and more different solutions and different approaches, and this is where you start researching different services that AWS has to offer. When I started working at AWS, I primarily used EC2, S3, and pretty much that's it. And over the years, where the demand for different solutions, different architectures, and different requirements actually grew, I started using different ones because it was much easier to do it this way, and the maintenance as well as the pricing model was extremely good. So I can assure you that the longer you work with AWS, you will know more and more and start using more services. But I don't know a single person, and I work with loads and loads of people. I also work very close with AWS, and I can assure you that not a single person knows all of those services because there's so many of them. It's actually almost impossible to know all of them. Yes, I can hear a few questions regarding the Docker, and if we can elaborate a little bit about the ECS itself. Now, I can mention a little bit. I don't want to go into too much into the subject because it's not going to be on the exam itself. I'm going to just mention it so we can move on quicker. Docker, does everyone know what Docker is? If no, I will explain a little bit about Docker. And I don't want to, again, go into much detail into that. Okay, Onkar doesn't know. Docker is basically an application, a system that allows you to run services in the containers. So think of it as you have OS running, so a server with let's say Windows server or a Linux server. It doesn't really matter what flavor you have. And then on top of that, you install Docker, and Docker can manage multiple applications within as a little containers. And you can run multiple of those on one box, which makes the box much better because you can actually utilize the full potential of the box rather than run one application on top of the OS, which is very inefficient. The question here, is it like a VMware? No, it's not. It's not a virtualization. It's not a basically it's not because it runs this application itself. So ECS itself is basically a service that harvests Amazon EC2 instances and allows you to run multiple applications on top of the OS in a very tiny sections. So it is a multi-app manager. That's absolutely correct. And the beauty of ECS as well as Docker, it allows you to actually copy and paste them across pretty much any other server, and it's fully compatible, which means you can run it anywhere on any hardware because it's independent. Which means as long as you have a Docker and the application runs in Docker, you can run it on multiple OSs, you can run it on multiple hardwares in multiple locations. That's the beauty of a Docker. So I hope I answered your question, and I would like to move to next slide if it's okay with you guys. Now we're going to discuss a little bit about AWS Elastic Beanstalk. Now, AWS Elastic Beanstalk is easy-to-use service for developing and scaling web applications and services deployed via Java, .NET, PHP, Node.js, and many other languages out there, also including Docker, that can run applications something like Apache, Nginx, Passenger, and IIS. You can upload your code to Beanstalk. Then AWS will inspect it, and it will then provision the resources in order to run it. What it means, it's a fully automated system administration. So all you need to do as a developer, for example, is that you upload your code, then it gets validated, and then all the resources needed for the application to run will be allocated to that, and you have a fully running application without worrying about compute, resources, memory, a number of servers. It's fully managed, which is absolutely great. Let's move a little bit further. AWS Lambda. AWS Lambda lets you to run your code without provisioning or managing servers. You pay for the compute and execution time. Basically, what Lambda is a serverless compute. What it means is, if you have a code, you can basically run a small self-contained snippet, something like a Java, JS, or Python, or any other language you want. The list is available on AWS website, what it supports, and recently they announced even more languages that it supports. And basically, you only execute the code whenever you need it. So all you're going to pay for is running time of your application. You don't need any servers for this, you don't need any resources, you don't need any memory, and all you're going to pay is the amount of time your application is running to perform its operation. I don't have to tell you how awesome it is, and I can actually give you a real-time example of a Lambda itself. We had a customer that had a job running overnight, and the job was pretty much simple, was basically taking Excel feed from one of the documents and parsing it and pretty much converting this into another Excel with a report. It was old-fashioned, and they had 2 servers running in order to do this, because it was AZ solution, which means those servers needed to be fully operational, hence they had 2 of them. The problem was that the client was a little bit unhappy because the cost of running those servers in the data center, as well as having people running those servers and cooling and all of that, was about $1,500 US. Just for the job that took maybe 30 seconds to actually do, to perform and then get it out of that. It was fully automated, so it was actually very good. So what we've done instead, we use Lambda, which we actually converted the code of the client, which still has the same functionality, with the exception of it runs automated via Lambda, and it executes, does everything it needs to do, and outputs the file exactly the same format that it had to do before. Now the cost for that was slashed from around $1,500 to more or less 5 US cents a month. Yes, that's 0.05 cents for a whole month to perform the same job as 2 servers were running. Lambda itself is also fully redundant, and when we showed the cost to the customer, he couldn't believe that the bill can be so low. And I see a response from you already, which is correct. It's amazing, and if you can use the service, I would actually encourage you to do that. I have a question. Backend, does it user shared servers? Backend, does it user shared servers to run a code? Yes. Basically, what Lambda is AWS spare resource running on EC2 in a pretty much automated fashion, that all you need to do is upload a code, and they will execute this code on the servers behind for you. It's a fully managed, which means you don't have even access to that. All you need to do is basically upload the code and tell the Lambda what the code needs to do. And based on that, the only resource it runs and is using is the amount of seconds or milliseconds that your application is actually running, and pretty much that's it. So it is using AWS EC2 servers behind that. on which data it runs this function. I don't actually understand the question on which data it runs this function. Havish, can you actually explain a little bit more if possible, so I can answer your question? The code, if it is generate the report. So what we've done is we basically rewrote this the application itself, which was I believe it was I think it was a little Java application as far as I remember. And basically what we've done is basically rewrote it to work with the Lambda to make sure that it's pulling from correct sources and outputs to the correct target. So we pretty much have the same flow of the application itself. So it was using Java, just to answer your question. But any other language that is supported can be used as well. And also you can convert a code from one language to another. If you feel stronger, for example, with Python or JS, you can convert the current one into the language you prefer and have exactly the same output. So so you can achieve the same thing. So basically what Lambda does is a function call. Yeah, I would say as long you can kind of think of it like that. Lambda executes a code that you wrote. So as long as you can write your specific function or requirement in a language that Lambda supports, Lambda can do it. And there are limitations of that. Like, for example, if you need to ask Lambda to perform multiple huge data pools from multiple databases across the whole world, maybe it's not the greatest. I would maybe then limit this to a smaller chunks and do it a little bit differently, and maybe use more dedicated hardware for that. But it's amazing when you have a smaller automated tasks, and the cost saving on that is extremely amazing. Okay, I have another question. Does Lambda require data to be stored in AWS environment, or this can be stored in your DC? It's actually a very good question. Now, we're going to get to this a little bit later, but you can link your DC with AWS resources via either VPN, or you can link it via the Direct Connect. And what it will do, it will extend a network for your on-premise or data center into the AWS itself. And so AWS itself can fetch data from your data center or on-prem as it would actually be working locally. So think of it as an extension of your data center rather than an additional data center that you currently use. I have another question. Can data be pulled from the data can be from anywhere. We will have to link that to our DB wherever it is. Lambda gets yes, data can be obtained pretty much from anywhere as long as you write this within your function, because Lambda does have a function to actually pull the data from different sources. You need to remember that by default, Lambda is only allowed to pull the data from within AWS itself. So as long as you have the data there, it's absolutely great. If you don't, you need to extend this via the VPN or Direct Connect in order for Lambda to extend the reach of the data itself for your function to work. That's great. So I would say we can focus on the Lambda a little bit more later, so I can explain all those features and functions. Let's move on maybe to another slide, which will allow us to move on a little bit. And we will come back to Lambda later, and you will have probably more detailed questions at a later stage. So let's move on. Another one is elastic load balancing, also known as ELB. What it is, it's a networking service that automatically spreads out incoming application traffic across several EC2 instances. Customers have option to enable ELB within a single AZ or throughout multiple zones. That service can also detect unhealthy instances and reroute the traffic in case of to the healthy ones. ELB basically is like a load balancer, like a physical load balancer. So if you have, let's say, two servers that that are working in front of ELB, let's say, in the normal scenario, you would probably need to deploy some sort of device in front that when the traffic comes in, it kind of can route the traffic in some sort of way to both of your servers. We use ELBs when you're trying to achieve higher availability or uptime. So in case one server goes down, the ELB itself, sorry, the load balancer itself can detect that and can push traffic only towards a single box, which means for the user itself, it shouldn't be a downtime because one box can handle quite likely more than more traffic, and it's basically redundancy implemented. So what we currently have in AWS, we call it elastic load balancing, and what it is a service because it's not physical device that you need to purchase and put it in front. It's actually a software written that it can route your traffic in between the instances. So basically, you have multiple instances. You'll be basically routes the traffic towards them, as pretty much as we mentioned here. And what happens if any of those instances actually is unhealthy or died or something happened? ELB itself will detect that, will stop serving traffic to the instances, the affected ones, and it will route the traffic only to the instances that are healthy. When those instances become healthy again, it will do specific checks that I can discuss with you guys later, and it will enable them again and start routing the traffic automatically. So I have a question: can ELB also run in a round-robin mode? Also, if it supports SSL offloading for web apps. Challenges is a very, very good question. I will answer this in two answers. One about round robin and other one about SSL. Well, round robin is a technology that allows you to equally distribute the traffic between two locations. And yes, since pretty much 2014, AWS introduced the round robin style routing because before they didn't have it, and particular traffic was pretty much one-to-one. So whatever goes to one server goes to other. But the problem was that when you had servers on one side that were, let's say, bigger boxes, and on the other side you had smaller boxes for any purpose, the amount of traffic going towards both of them was pretty much equal, which means the instances with a bigger, more performance were getting less utilized, and the smaller instances or server sizes were overutilized, which means they were working kind of overtime. And since 2013, AWS introduced round-robin style feature that allows you to actually route the traffic equally to all of the boxes, no matter what the size. So it will detect how busy they are, and it will actually spread the traffic equally. You can also enable additional features onto this, which I will actually discuss with you later on what kind of features are available. But yes, it's available. Now, regarding the SSL itself, yes, the ELB itself supports full SSL. Sorry for my writing. I'm not an artist. What it is you can upload your certificate directly to ELB itself, and all the traffic from pretty much internet itself going to ELB will go via the HTTPS, which means it's fully encrypted. Now, ELB itself and the connection between ELB and instances is not encrypted. You can enable this if you want for additional security, but that's all within a network, restricted network itself, which means there's no need for that. All you need to do is upload certificate in a single point into the ELB itself, and the rest is fully encrypted. So it's actually amazing because you only need one certificate. You don't need hundreds of certificates for all those servers. And if you're spinning multiple new instances, all of them using exactly the same certificate behind. I have another question. How load balancing will check whether my application is down or not? Let's assume server is not down, but the application which is running on the instance is down. How it will detect this? Well, it's a very good question. It's a very valid one as well. AWS itself has a few checks. It can run a HTTP check, which means it will check for a response, let's say, to 100 from the web server. It has a TCP style checks, which can check if the port is responsive, which means, for example, if your application, if you're trying just to check if maybe SSL is responsive, because that's all you need to do, you can set up a TCP on port 22, and if, for example, any server is off or SSL is not responsive, then TCP check will fail, and the instance will be removed from ELB, and the traffic will stop flowing there. In case of web servers, you can use HTTP style checks, which means if you have any other response than 200 to a link that you are specified on the ELB itself, then it will actually detect, for example, 404, page doesn't exist, or you might not even have response at all. What will happen in this case is it will detect this and it will remove this particular server from the pool because it's affected. So I hope I answered your question here. Instance means it's server instance. Yes. Yes. Sorry, I'm using the instance word so much. I worked within the AWS for past 7 years, and once you started working, you pretty much never call servers anymore. You call them instances. The reason behind it is because you don't treat them as a servers. You actually use them and decommission and use and reuse. Basically, you treat them like a box of tissues. You only need a server for specific tasks. You use it, and then you decommission it. And you pretty much do the same. So we call them instances. And the reason for it is it's reusable. You don't pay for hardware anymore. You don't need to use the same server over and over again. All you need to use is the same server only for the purpose of a specific job. Once it's done, delete, terminate, and you can spin up a new one straight after. So that's pretty much the answer to your question. Another question is, does the application need to keep the heartbeat communication with ELB? Yes, it does. However, the heartbeat itself is originating from ELB itself, not from application, which means the heartbeat itself, either via the TCP or HTTP, originates from ELB and goes towards the instance. It pings every few seconds, and that determines if ELB itself can connect to the instance itself. And there are a number of faults that and failures that it can accept, beyond which it can remove the instance from the pool if it's unhealthy. Another question, does the ELB support session stickiness? Yes, that's a very, very good question. ELB does support session stickiness, which means you can tick basically one box in an ELB setting, which I can show you later on during the session once we're actually going to discuss ELB in detail. And what it means that if, for example, a user goes through ELB and has, let's say, a session open that keeps their basket running. So, for example, someone went to Amazon.com and you have your basket in the top corner that you have running. Quite likely, you went to the ELB and you're allocated to one of the instances that keeps this state of your basket. Now, what would happen if you would go to other server? Suddenly, you wouldn't have the basket because that particular basket here doesn't have your info. What would you need to do is enable session stickiness, which means every single time this particular user is requesting an update from the basket or does any particular operation, it goes through exactly the same path and always ends up on the same server. So yes, it does support that. Another question. Can we extend ELB as per load requirement to our servers? Yes, that's actually it's the whole point of using ELB is to be able to scale vertically rather than scale horizontally rather than vertically. What it means is you have a single ELB and you have a pretty much internet connecting to it. So basically, you have some sort of website. And in this particular website, let's say you have 2 servers running. Yeah. Now, what it means is to the user, always only ELB is visible. No matter how many servers you have behind, only ELB is visible. What it means is, in case, for example, that you have, let's say, 50% of traffic flowing, just because it's a, let's say, not very busy day, you need only 2 servers, which is absolutely fine. All of them will get obviously 50% of traffic each, because they're running in the round robin mode, and that's absolutely fine. But imagine what happens is there's a sale, or there is a peak of traffic, or someone posted something and there is a spike of traffic on your website and it goes to 100%. Sorry, 100%. Yeah. What will happen then is you can set up ELB in the way that it can add additional servers, which means the traffic suddenly drops from 50% here to only 25% per box, and all the server pool can now handle much more traffic. And there's almost virtually no limit to how many servers you can have. So you can spin up as many as you want, or you can have as many as one. I would always highly encourage you to have always at least 2 servers behind ELB, because obviously servers can go down and up, and it's just basically a hardware that can have a failure. But running at least 2 servers behind the ELB is the most efficient and the most amazing way, because it will allow you to have amazing uptime, as well as you can scale up whenever needed, or scale down if you don't need it, and save money. Another question I have. Another additional question I have is the traffic within the ELB network after the ELB is sent in the clear. Does this pose any security issues? The answer to your question is yes and no. Now, we all know that within a region you have multiple AZs. What it means is that you have multiple data centers. Now, if you have an ELB, that means that quite likely, if you want to spin, let's say, 3 different servers in all 3 AZs to have a full redundancy, the network and the request will go between data centers. Now, the data centers are connected via super quick fibers, which is not encrypted. So, if, for example, you have, one day, let me make it a little bit smaller. Sorry for that. If you have, let's say, one data center here and one data center here, the connection between them is not encrypted whatsoever, which means anything behind ELB that goes to both of those data centers is not. Everything that is before ELB is fully encrypted if you enable SSL, obviously. You can actually enable SSL on all of those data centers and make sure that ELB itself and all the instances behind are talking. And the good news is that you don't need a fully signed certificate to do that. You can have self-signed certificate, because as long as it's fully encrypted within, the ELB doesn't care if it's fully signed or no. All people will see is the certificate that actually sits in front of ELB itself, which means it's great. Is disaster recovery enabled in this system? It can be. We have a feature called self-healing, or also known as auto-recovery. You can specify that any instance behind in the pool, once it's dead, let's say this particular box died behind ELB, what happens is this particular box, if ELB detects that this particular box is dead, and you set up that minimum amount of servers I want is, let's say, 2, what happens is this box can be decommissioned or terminated automatically, and the new box in its place can be created, and traffic can be automatically routed here. So yes, it can be enabled. I see we have quite a few questions regarding ELB. I would say maybe let's leave maybe the rest of the questions, if possible, up until we actually reach ELB itself, because I'm sure you have more than that, and quite likely I'm going to give you amazing real-life scenarios, what actually happens in specific cases, and how we use it and when. And then you can, based on that, you can ask more questions. That's just a little bit of overview, and I really didn't want to dig into much because I can answer all of the questions, trust me on that, and we can talk for hours, maybe even days, which would be awesome. So, if we may, we finished just now on ELB of what it is, and we went into details of different features and settings. People are asking, which is great. I can see another question already. ELB routing the requests to instances. I would say, if you can keep this question for now, we will discuss that particular question and how it actually works in the detailed section, probably on section tomorrow, where we're going to be discussing EC2 and ELB in much greater detail. So if you can remember this question, that would be absolutely great. At this current stage, I would like to just go through overview, which we are trying to focus on, and then we're going to move to a much detailed material later on, and pretty much probably going to have even more questions than that. So let's move on. Now we're moving into the territory of storage and content delivery. So you will be able to find it in the AWS console under the storage and content delivery. You have the different services underneath. You have a S3, you have S3, you have a CloudFront, you have Elastic File System, Glacier, Snowball, and a few others. And I'll discuss this with you pretty much right now. So, AWS Simple Storage Service, also known as S3. Pretty much nobody is using a long name, Simple Storage Service, while working in AWS, because we are trying to use the S3 shortcut as much as possible, as well as EC2, as well as VPC and other ones that you have out there. I will pretty much, on every single new occasion we have a new service introduced, what we will do is we will describe what it is, and from this moment onwards, I will use the shortcut, as well as occasionally I will also mention the full name, so you remember that, and you'll be able to associate this with the shortcut itself. I have a question: why CDN is available with storage section in AWS? It's a very good question. The CDN is available because it is a part of AWS. It's a service called CloudFront, which allows you to basically host files to users, as we discussed, available in over 190 countries. And it is a part of the storage because it is linked directly to the S3. When you create a bucket, you can then S3 bucket, which is the storage itself, which I will give you an idea later. You'll be able to create a CloudFront out of that, which means all the content of this bucket will be distributed globally in the same time, which means it's available as a content delivery network. So I will go into this detail in a bit. Let me discuss the Simple Storage Service first. What it is an object-based online storage service that offers unlimited data storage space in the cloud. What it is, it's a place to store all your files. It's as simple as that. You can store images, you can store other assets for websites, you can keep backups, you can basically share files between servers and different services that you're hosting. It can also host static websites. Additionally, many AWS services write and read from S3, and that's basically a description of what it is. S3 itself is probably one of the most important after EC2 service that you probably will need to know or want to know, is because it's used everywhere and every single time. Every single time you need to write something to a file, you can write it on the server, but if you have the two servers that need to share something, quite likely S3 is part of your solution. Also for backups and for storing any data, S3 will be used, and that's a key feature of that. So let's move to the next slide. storage and content delivery. So, CloudFront. CloudFront is a content delivery service, also known as a CDN, that I actually just explained also in the previous question, that integrates with other Amazon's cloud services to provide easy way for businesses and developers to distribute data through high-speed transfers. You can make a website load faster by spreading a static file delivery to be closer to the user, when used globally of a network of pretty much all the edge locations. What it means is, as I described before, if you, for example, connecting to the servers in US and you're connecting, let's say, from Asia, then the latency obviously between those two locations. Let me just try to doodle it a little bit for you. So that's, let's say, US, and that's Asia. And I know that they don't look like circles right now, but that's just for the purpose of this particular session. So if your server is actually hosted in the US, this is where your box is, and your clients are connecting from India itself, let's say, what means is that the connection is pretty much going over pretty much all the countries all the way to the US. Hence the latency and the delay of how quick you can obtain the data from the server is slower, because it needs to travel pretty much across whole globe to be able to request something from your server. Now, what CDN is a point or location nearest to the user that will be able to obtain specific file instead of trying to get the same file from the server. So initial connection might be still to the server itself, but then if the server says, hey, I want you to actually fetch a file called abc.jpg because that's my logo or something, instead of your browser going all the way to the US and trying to fetch this from this particular box, what it actually says is, hey, actually, you know what? I have this file in here, so why don't you just go there and just fetch this file? And that way, the latency here, as well as the time needed for your web browser or any other application to get the particular file, is reduced hundreds of times. And actually, not only that, but also number of requests hitting the web server here is reduced because nothing actually hits this after initial connection, which means all the files can be obtained from that particular spot, which is great. And you can have this particular file or copy of this in 190 locations around the world, which means no matter where the connection is coming from, quite likely there's something nearby to get the data from. And that's exactly what the CDN is. It's amazing. I used it multiple times. It allowed us to actually have a service that are much, much smaller, because you don't need people to obtain the data from the servers anymore. They just basically obtain the structure of the website, let's say, so the index file and the CSV, and then the rest, like images and all the PNGs and everything else you can think of, is actually grabbed from the nearest location. Also, you can share different files like PDFs and pretty much Word documents from those locations, which means people do not download those files across the world. They download them locally, which actually works for them much, much quicker, and the transfers are insane because they are local. Now, next service is called Elastic File System. What it is Elastic File System is a network-attached storage, also known as NAS, in the cloud. It's been introduced probably around a year ago, and it's a storage that can be attached to multiple EC2 instances, so basically multiple servers. It provides block-level storage. Currently, it's only available in preview in AWS US West region. It doesn't feature regularly in exam at the moment, however, later it will. Now, it's worth mentioning that's a new feature that AWS came up, because so far people were complaining a lot that EC2 instances cannot share data. Yes, you can upload data to S3, which is great, but S3 is not, it's not block level, it's object storage, which is very important. And the difference between those two is block storage can be indexed. Your system can know what files are there. Object storage cannot be indexed, which means the data you can upload there and the data is persistent. However, the system cannot know where the file is. What it means is that you'll need a specific link or specific path in order to get data out of S3. And on block level, which is Elastic File System, you don't, because the system can actually use a normal Explorer or command line, and you can actually see the content of the file, while in S3 you cannot. So AWS came up with this block level storage, which basically is also called elastic file system. Now you can basically create elastic file system, which is a storage, and attach it to any instance you want. And a good example of using it here would be if, for example, you have maybe a web server or anything like this. All you have is a bunch of files that you always want to have available. And no matter how many servers you want to spin up, you always want to make sure that all of those servers have access to the same files. Which means you attach EFS to all three of them. It's a central point, and it works like this. Now, at any stage, any of those instances will be able to access the files, will be able to change them, and the instance to other systems is instant, which means the change happens straight away. So you need to make sure that when you're writing an application, is that there are not that many, not too many changes to one file at the same time, because it takes a little bit of delay. And if, let's say, you have a pool of 100 servers in your application, and all of them are writing to one file, well, application can go a little bit confused because it takes a little bit of time before the file gets synced or updated. We're talking here about milliseconds, so we're not talking about seconds, minutes, or even hours. We're talking about milliseconds. But imagine that all those 100 servers are requesting the same file or changing the same file 100 times a second, times 100. You can imagine how much traffic there is, and quite likely the application will maybe even crash or slow down. So you need to make sure you understand that, and you can use it, and you can share specific data. But if you need to perform a lot of operations on a specific file, I would encourage you to maybe store the file locally and perform those on each single server, so it doesn't affect essential storage. It's pretty much the same as saturating a network link to a single NAS server, and in this case, obviously, more you request, slower it gets up until it stops. So this is how it works. I can also answer a few questions. As you said, EFS is NAS. So how the block level storage as NAS, our file level storage come from fillers. Basically, the question is about from Charanjit. The question is either it's a block or file level storage. It is a block level storage, which is the lowest form possible. That means that the system can actually write any file to it, can have a system on it, and pretty much can even run off it. File level system is one step beyond, when you can only write the files, and pretty much that's it. You cannot run a system of a file level storage itself. So pretty much, and all the servers will have access to each block of the drive in a full permission, which means they can operate and do any operation. So if you, for example, want to run a full AV scan, you have access to every single potential block of this storage, which from my point of view is pretty much like any other hardware that you have in your computer. You can do anything to it. You cannot actually run OS, or you cannot run anything of your NAS, or like in the living room maybe, or in the data center. You cannot, because it is dedicated like this. Yes, you can run VMwares and you can have iSCSI and all of that, but on the block level, that's the closest you can get to a actually physical hard drive in your computer or in your server, while actually being on the network. Another question is, how does EFS distribute the data across clusters? It's actually simple. It actually doesn't have a clusters. What it means is it creates a single, let's say, shared folder that is available, and all you need to do is basically map this particular folder to all of your servers. It's a single central location for all your files, and basically that's it. So that's as simple as this. I have another question regarding respect to the large files. Regarding the large files, I will give you all the breakdown of all of that in the future. However, in the future sessions. However, At this current stage, Elastic File System is not on the exam itself, and you quite likely will not have any questions from it. I don't want to commit too much time towards that because I would like to focus more on the stuff that will be on the exam. I'm more than happy to answer your questions. In fact, I encourage you after the session itself to ask any question you want on our Simply Talk or submit a ticket, and you will get a full response with the links and everything else, and chat on the forum, and you will get loads of responses there. Every single question you have, I'm pretty sure there's an answer for it, and I'm more than happy to give it to you. Today, because the session is only 4 hours, I would like to do as much as we can, and to cover as much as we can. So sorry if I cannot answer all of your questions. I tried just few. So let's move on if possible. Another service is that we're going to discuss today is called Amazon Glacier. What Amazon Glacier is a long-term backup and archiving service in the cloud. It takes backups of your backups that you keep on S3. However, you should refrain from retrieving data in a hurry. What it means is as simple as this. Imagine that you have an S3 bucket. Yeah, you have an S3 bucket that you doing all of your backups from all the places in the world or from all the servers, let's say around the world. That's great. Now, S3 itself is a very good as a storage itself, and it's extremely redundant. It actually has got 99.99999. In fact, after the dot, there are 11 nines of how good it is, which means that one file probably will be lost every something like 300 years maybe out of every single file you ever upload, which is insane, and it's replicated globally. Which it's actually replicated within a region, which means between multiple data centers, which is almost impossible to lose your file. However, I don't want to go into details in that because I want to explain Glacier. What Glacier is, you can set up a Glacier Vault. It's called the Glacier Vault, which will actually take all the files from S3 that you currently have and push it to the vault. Yeah, and that's I'm gonna call it Glacier. Now, that particular behavior can be scheduled, can be automated. You can set up a specific policies on S3 saying any file that is older than, let's say, 30 days, I want this to go to Glacier. And the reason why we would want to do this is because for AWS, it's pretty cheap. I will need to fetch the latest numbers because those numbers actually recently changed around a week ago. And now they became something like a 32% cheaper. So I don't want to give you the wrong numbers just to give you an idea. But the principle is that let's say, for the sake of this exercise, that the cost of AWS is 0.03 cents. Yeah, it's less, but let's just say that. I can assure you that the Glacier cost is 0.003. It's 10 times cheaper per gig, which means if you have a lot of storage that you use on the S3 and lots of files that you keep them as a backups, I would actually encourage you to keep everything in the Glacier because it's going to be 10 times cheaper for you. The only downtime of Glacier itself is that when you're trying to restore data, and that's the biggest difference between S3 and Glacier, is that it takes up to between 4 and 6 hours for the data to be available. Because what AWS will do is probably they will take a tapes or backups or somehow and restore all the data from some sort of source. Nobody really knows what it is because it's a top secret AWS service. And what they will do is they'll restore and make it available back to the S3, which means after that you can connect to S3 and fetch all your data. And that's pretty much it. And that's the secret. So if you ever hear any questions on the exam that we're probably going to discuss later regarding that I want to archive stuff, I want to keep it for long, and I don't want to really access, to my files straight away, Glacier is quite like the answer because it's extremely cheap and it's a long-term storage solution It's a backup of a backup, basically. So that's what the Glacier is. Let's move on a little bit further if we can. Now, we have another service called AWS Import Export Snowball, which is a part of the import export service used to move large amounts of data quickly without using the network. Okay, now what it actually is and what does it do? Okay, imagine a situation you have a data center. Let's say I'm going to draw a data center, DC, and in your data center, let's say you have, I don't know, let's call it 100 gigabytes of data. Yeah. Now that's maybe not a lot, which is fair enough. You might have 1,000 or you might have 1,000,000, just for the sake of the exercise. Now, in order to send this data to S3, normally you would basically connect your DC to S3 bucket, S3, via the internet, and depending how fat the pipe is and how quick it is, you will then have to wait, depending on how much data as well it is, you will need to wait maybe minutes, maybe hours, maybe days, maybe even months. In some cases, I can assure you, maybe even years for this data to actually go over. And not always everyone's got years to wait for the data to be sent. And sometimes when you have a migration process, like I want to migrate all my, I don't know, all my files into the data from the data center to the S3, so to the cloud, you might have a situation that the files actually are changing. There are more and more files because it's a live production environment. And if you're going to start uploading those files, they will never finish because the amount of data probably being added to amount of data being sent to S3 is more, which means, you know, this process can take years. And depending on your line as well, if you have, you know, if you're lucky enough to have like 1 gigabit line, that's great. Sorry for it's my mouse. 1 gigabit line, that's great. But if you're only on, let's say, 10 megabits or maybe 1 megabit connection or even ADSL, trust me, you will never upload those files to the S3. Now, this is where Snowball comes in. What Snowball actually is a physical appliance. It's actually a box, a size of, I would say, medium-sized carton box that it can be carried around. I've seen one before. It's pretty much awesome. And what it is AWS will send you this particular box to your office or home or wherever you need it. Then you connect this particular box to your infrastructure. You can connect via the fiber, you can connect via the network, you can connect via the, there are different ports on it, you can read much more information. I'm just giving you a little bit of overview of what it is. And then what you do is upload all your files locally via the fastest possible way onto the box. So it's like basically they send you a big hard drive. And all you need to do, once you upload it, you basically call AWS. There's a label on it. You call AWS carrier. They come, they take the box, and the same day deliver this to the data center. All that AWS does is connects this to their infrastructure and downloads all those files that you just uploaded into the S3 bucket. Yeah, and that takes maybe 3 days if you think about it. If you have, let's say, obviously that depends on the amount of data you have. So one day you will get the appliance, you upload all the files. Second day, pretty much delivery happens, and the third day all your files are available. If you have obviously petabytes of data, then it quite likely will take longer than that, I can assure you, but it's doable via the hard drive rather than sent via internet. And that's what pretty much Snowball is. I can tell you off the record a little bit that around a week ago on the Rain event, AWS introduced a new thing called Snow Mobile. I can assure you that's not going to be on the exam because it's such a new thing that it just basically was released. What Snow Mobile is, it's an upgraded version of a Snowball. And what it is, I'm going to draw it here. It is a truck with a trailer. Basically, what it is they drive this thing into your data center. They connect it via multiple fiber links, and that particular thing is capable of storing 100 exabytes of data. We're talking exabytes now. We're not talking gigabytes, petabytes. We're talking exabytes of data. That's a container that is huge. They bring it to your data center, they connect it to everything you can, upload the data, then they drive it to AWS, and they do exactly the same thing over and over again. So it's not a small portable, it's a whole truck. So that's obviously, bear in mind if you have a huge data center migration, maybe instead of having hundreds of those, just to be able to do that, maybe it's easier to just call AWS and say, send me one of those. But that's just for your interest, and I hope that was interesting, and we can move on to the next slide. Now, what do we have? In next is a storage gateway. What it is used to increase the capacity to store files, such as Word documents. For example, also you can keep any other files. It also simplifies the process of file retrieval from your corporate network. All you need to do is set up a VM in your data center, and it will replicate all the data between AWS and your site. It's a cheap way of actually expanding your storage. So that's pretty much it. What it is basically a service that replicates data from one point. Either it's your on-prem or AWS. You can actually have it both ways. So if you decide that I want my data from on-prem to fly towards AWS, you can set up this way. Or you, for example, think about migration and you want to, you know, that's the process. If you think about migration, you take your data from on-prem here. But you might have a system that is hybrid. You might have a system that is partially hosted in AWS and also partially hosted in your on-prem, in which case the storage gateway is awesome because it syncs the files between those two locations, which means that if whatever your application is using on AWS connects here, all the data will be exactly the same here. And if you have another bit of application that's connected here and changes data, that means that it will sync directly. And that's all with storage gateway. I have a question. If we talk about storage, which means S3 bucket. Yes, that exactly is S3. When we're talking about storage, we always, pretty much almost always talk about S3. What it is, it actually, you point this to S3, and that particular S3 is being replicated by this particular service all the way to your on-prem. And that's pretty much it. It's no user interaction, it's fully automated, and everything goes over the internet. You can also have a VPN, you can have a direct connect, which we're gonna speak about this later. So there it is. Let's move on to the next one. So now we reach the section of the databases, which some of you might be very, very familiar with, as I know from introduction, which is absolutely amazing. Now, in databases, we're going to have services like RDS, which is a relational database service. We're going to have Dynamo, which is a managed NoSQL database. Elastic Cache, we have Redshift, and DMS, which is the managed database migration service itself. All of those are falling under the database, and I would like to discuss them in a little bit more right now. Again, I don't want to go into too much detail. That's just basically overview of what AWS has to offer. We're going to start with the RDS, which is known as Relational Database Service. That provides scalable relational databases in the cloud through the web service. It manages databases administrative tasks. It also automatically patches databases on your behalf. What it actually means is RDS is fully managed database. What it means? Simple. If, for example, you have a SQL Server, you have Oracle, you have any other database pretty much you can think of, you can have it running on AWS with pretty much the same setup as you would have on your on-prem. There are a few limitations that we will mention during the more detailed session, but everything around RDS is fully managed, and that's important. All you need to do is connect to the database and start uploading queries and read and write and all of this. As an RDS, you don't have access to the OS. You don't have access anywhere but the database port itself that you can create databases. And the reason why AWS did that is because they fully manage that. They allow you, they basically patch the whole thing for you. They allow you to do lots of other things around it, but because it's fully managed, they restrict you from doing specific things. All you need to do is basically connect and start using the database itself. So, next type of the database, sorry, not next service that AWS provides under the database section is AWS Migration Service. It's basically a service that replicates, migrates, and converts the existing databases into AWS. But also, funny enough, it works other way as well. You can take stuff from AWS and convert this into your on-prem data center. Maybe because you want to take a backup. Maybe because you want to have a copy of it somewhere else just for DR purposes. It actually it works both ways. So what it does, it takes exact copy of the database and puts this on the AWS RDS itself. You can also use this service to convert from an engine like Oracle, for example, to something like Aurora, which is the AWS database system that they came up with. Now, obviously, when you're converting stuff using this tool, quite likely you want to make sure that your application itself supports this. And I can tell you for sure that running systems on Oracle, for example, can be quite expensive, as you probably already know, based on your bills and licenses. If you migrate stuff to Aurora database, it's quite likely going to be 1/10 of the cost of what you're currently running. Because for Aurora, you pay for minimum for storage, and you also pay for amount of queries you have, rather than for the system itself. And pretty much that's it. You can convert, the list is long, but I will give you more examples of that in the future sections when we're going to be discussing that. If it's okay with you. I know that you have lots of questions here regarding Aurora and all this stuff, and quite likely I just hit a gold mine and you had 1/10 of the price. I want to go there, which is great, but I would focus on Aurora exactly in the Aurora section, which we're going to discuss a little bit in the future. For this particular state, I would want to maybe skip a little bit towards the next slide. It's just an overview. I just gave you a little bit of idea. Let's skip a little bit more, if it's okay with you. So, another one under the database, it's DynamoDB. What it is Amazon version of NoSQL Server. If you ever have requirements for NoSQL database, you can use DynamoDB, and that's pretty much what it is. I will give you more examples on that once we actually reach a dedicated section for that. And I'll give you all the ideas about cost pricing, about how it works, and about pretty much all the bells and whistles it has to offer. Let's skip to the next one. Next one is Redshift. Okay. Next one is Elasticache. Amazon Elasticache is basically a service that runs in front of the database. You can put it in front and acts as a cache. What it is if you have users, a website, and those particular users are actually requesting the same stuff over and over again from the cloud, yeah, from the server, and this server connects to the database, let's say. Every single time someone connects to the web server and server requests stuff from the database, it basically runs a query, and the queries are kind of going all the way around. Now, the database itself is not necessarily designed to do hundreds of thousands of instant requests, and if you want to keep the cost down, definitely you don't want to use beefy server because it will cost you a lot. So what you can do is use a service called Amazon Elasticache, which actually sits exactly here, and all of the requests are going through it, which means if someone already requested that particular information, it will be cached in the memory here, which means the data only travels here, and it actually never goes there. And obviously, if the query goes, there's some new query that is not cached here, it will pull the query all the way from the server, cache it more here, and that service here is extremely quick and extremely cheap as well, which means your database at the back end can be super small, and most of the queries, in fact, about 80% of the queries that nowadays lots of systems are doing can be fully cached, which means for a single query, you only need a single request up until it's cached, and then everything is served. It's fully automated as well, and you pay only for amount of queries you have, hence cost saving. So, which is great. I'll move on to the next slide, if okay with you guys. Another one is Redshift. It's basically an Amazon data warehousing service, and basically all I'm gonna say right now is that you can store huge amounts of data across multiple databases, across multiple systems, and you can then process this data with some smart technology behind that. I'm not going to give you too much detail right now because we will dig into this in the future sessions. So that's just overview of what's to come. So now we're going to do some knowledge checks. I hope that you listened and you remember a few things. So if you did, let's go for it. Question 1. What is AWS service? What AWS service is used to run Docker? Is it A, Elastic Beanstalk? Is it B, EC2 container? Is it C, Lambda? Or is it D, Direct Connect? I can have quite a few answers already, and I can see every single person answered B, EC2 container service. So check. That's correct. Absolutely great. Listen, guys, I don't think you need to do this course anymore. I think you know it all. So, you know, that's absolutely 100% spot on. Great. Let's move to another question. What is the Amazon NoSQL product called? Is it called RDS? Is it called DMS? Is it called Redshift? Or is it called DynamoDB? I can see the answers flowing. And the answer is D. That's correct. Pretty much. I mean, you know what? Everyone answered D. That's incredible. You know it all. Another question. What service would you use to archive data for long-term storage? Would you use Glacier? Would you use Snowball? Would you use S3? Or would you use Storage Gateway? Answers are flowing. The correct answer is A. And I see that one person made a sorry, yes, my mistake. You didn't do a mistake. You corrected it. That's correct. For long-term storage, a data archive, as I mentioned before, you always use Glacier. Why? Because it's simply the cheapest and it's a long-term storage, which means you don't need to access it pretty much frequently. That's great. Everyone answered this correctly again. I'm actually impressed. It's awesome. So, next section is network. In this section, we're going to have a little bit about, sorry, my mistake. In this section, we're going to have a little bit of VPC. We're going to have a direct connect, and we're going to have Route 53. I can assure you that at least VPC and Route 53 are the services that you're going to use pretty much all the time. In a medium maybe organizations or even bigger, you will always use direct connect. And I'm going to explain why in a few seconds while we reach the particular slide. So let's go for it. So, VPC. VPC stands for Virtual Private Cloud. What it is, it's a virtual data center and works as a bridge between user and existing infrastructure on AWS cloud. What it is, it's a safe place and secure place, and the most probably known is the private place that you pretty much store all your resources in. So all the servers, all the databases, all the security rules, everything you can think of is contained within VPC. I can explain from a technical point of view what it is. Think of VPC, and maybe not everyone will understand that, but from networking point of view, what VPC is, It's basically a VLAN. What VLAN is a dedicated network for all your resources on a switch. Let's say you have a switch in the office, and you have this particular switch works between, let's say, two departments. And there are lots of boxes here, those are ports. Yes, I know it's not ideal, sorry for that. And those ports working with department, we have a, let's say, finance department, and then we have another department that is maybe, I don't know, maybe media. And someone decided that both networks between those two must be fully independent and they're not shared, which means nobody from media should see what is in finance and nobody from finance should see what is in media for some reason. In this case, what maybe network administrator would do is create two VLANs, maybe VLAN number 1 and maybe VLAN number 2, and whatever is within the VLAN itself is only available to this particular users within the VLAN, and what is available in this one is only available to those people. So to recap, a VPC is basically a container or a network container around every single thing you will ever launch into VPC, sorry, into AWS Cloud. And you can have multiple VLANs, you can have multiple VPCs, depending on what kind of structure you want to do, and we're going to give you lots of examples in the future. Why would you want to have multiple ones, and what are maybe the issues with that, or maybe what are the pros of having one, what are maybe the limitations as well. And nobody else except you and all the resources have access to this particular VPC. So everything within is secured and it's private. I see question here, is trunking also done like VLANs? Yes and no. Now, VPC itself is a managed service, and when you mean trunking, I presume you mean linking two VPCs between each other. It's doable, and we call it VPC peering in the VPC. So if you have a VPC1 and VPC2, you can basically create a link between them, and that is called VPC peering. And you can say, I want that particular VPC to be able to talk to this particular VPC, and that is fully connected and working together. I can see loads and loads of technical questions flowing now, and I knew we're going to have that. I will say, I will give you all those technical answers in the next few sessions that we're going to have, because we're going to focus on the VPC in a much better level. I know we can, honestly, I know we can sit and talk maybe a week about the VPC and how different technologies and how different features actually work here, but it would be easier and quicker for all of us to just contain this information and move it to the session that actually will discuss VPC directly. Up until then, it's just basically a first lesson for everyone to understand more or less what systems we have and what services we have. And I think we're going to move on a little bit, and I think we need to speed up a little bit to be able to finish today's session on time. So sorry if I cannot answer your question right now, but keep this question and I'm going to answer this on the session once we come near the VPC itself. I hope this is okay with you. So another service is called Route 53. If you think of Route 53, what it is basically a DNS. It's an Amazon DNS, and you can register domains with the Route 53. You can host multiple domains and records in there, and you can have it geo. You can have it geo DNS, which means you can have it worldwide, and it's basically DNS as a service. That's all you need to know at the moment, and we're gonna focus on that in the more detailed session later on. And that's pretty much what I wanted to do and say about Route 53 for now. Another one is called Direct Connect. Direct Connect is basically a way of connecting your resources into the AWS environment. So imagine a situation you have your data center or your on-premise, and you have a bunch of servers sitting there. All you want to do is basically expand your network of using AWS resources. all you're gonna do is create an AWS Direct Connect. There are other ways of doing that. Don't get me wrong. You can do VPN, and you can also use the internet just to do that. But Direct Connect is the quickest, shortest, and the least latency solution out there, because it actually maps with your data center and also MPLS connection. So basically, your list line directly to AWS resources, which means you're going on the shortest possible route into the AWS, and it's extremely stable. You do pay for it a little bit, don't get me wrong, it's not cheap and it's not free definitely, but if you work in the big organizations, all of them are using Direct Connect because it speeds things up. I have a question. Can we have a simple high-level picture showing a position / boxes of AWS components if learned till now, like an example diagram, if application is hosted in AWS? And is this particular question, Omka, regarding the Direct Connect? No, it's all the components till now, meaning how we will the picture look. Okay, actually, I'm gonna note this question right now for you, and what I'm gonna do is once we finish today, I will come back and I will draw this little doodle of mine to explain this. But I really wanted to finish the session first, and then I can answer your question in the last 15 minutes of our time for today. I will be able to explain a little bit more. So sorry if I can answer this right now. I do not forget that, and if I do, please remind me by the end of this. I will be more than happy to do for you on my screen. So let me switch to the next one. Now, another section we have today is called Analytics. And in Analytics, we have EMR, we have a data pipe, we have Elasticsearch, we have Kinesis, and we have machine learning. Since the reInvent last week, they introduced few new ones. And the list is probably a little bit longer than that, but for the exam, you only need to know quite a few of those, and I will go through all of those with you guys one by one. What media? I have another question from Umesh. What media use in the case of Direct Connect? I don't understand the question. What do you mean by media, Umesh? What internet? Okay, basically, coming back to the slide before, just to answer Umesh's question, is basically what internet is used in between. Now, AWS has a peering agreements with all the biggest tier 1 providers in the world, that's why they are so pretty much present in all the 190 countries, which means they bought a huge data links in between, shortest possible routes in between the data centers and all the premises pretty much you can think of, any location in the world. When you purchase AWS Direct Connect, that means that they will link you via their own link and guarantee the bandwidth you're actually buying. So basically, it's like almost leasing a lease line between the data center and AWS. It's unthrottled. Basically, there's no limit to it, and it's extremely quick because it's peered directly between the data center and AWS resources, and it's the quickest and the shortest route possible for you to get the data. So I hope I answered your question. There is no internet provider that prefer. Depends on the country. So they have different agreements with different countries depending on what is present there and who is the best. As simple as this. But it's a very valid question. Let's move on. So actually, I have another question. Can we say it's like express route link? Yes. Basically, you can. It is exactly the same thing. In Azure, you call it express route. In AWS, you call it direct connect. So it's exactly the same. So next session. In analytics, we have a service called Elasticsearch. It allows you to use the popular open source search and analytics engine as a managed service on AWS. And that's pretty much the description of the service. I will give you all the information about it in the future when we actually focus directly onto this. That's all it is to it. Another one, Elastic Map Reduce. What it is, it allows businesses and developers to process large amounts of data using a Hadoop framework. It is useful for processes like data mining and scientific simulation. Now, I can say that Elastic Map Reduce is not the most popular service of AWS, because simply most of the time you're gonna work based on your experience. You're gonna be working with everything but EMR, so Elastic Map Reduce. What it's actually used for is to take petabytes of data from different sources and analyze it in a massive ways. And what it is, it's actually spinning up huge amounts of servers and links them together, and via the Hadoop itself cluster allows you to do specific operations and have specific output like scientific simulations or maybe log parsing or all of that. But I worked for huge organizations in the world, and pretty much enterprises pretty much for past 15 years, and I can tell you that nobody ever wants to go near this because there was never a need for that. They always have some sort of tool that passes the data in some sort of way, but that is designed for huge simulations, like NASA is trying to maybe compute something and they upload hundreds of petabytes of data. So quite likely for us humans, we will never reach this level, and that's pretty much what I can say about that. We will pretty much go to this in a more detail in the future. Now, another one, we have a service called Kinesis. It's a way of streaming data to AWS. Kinesis can ingest lots of data very quickly from a mobile app, let's say from the sensors and other. What it is basically it's a collector or connector that you can push loads of data into the Kinesis itself. It absorbs all the data from different sources, and you can basically process this data in some sort of way. And pretty much that's it. That's all the information at this kind of stage I can give you. More to come. Another one, it's machine learning. Now, that's a scary thing. It's like the machines will take over the world, right? Now, what it is, it's basically, this particular service can predict the future behavior from existing data for problems like fraud detection or people that bought X number of things or bought Y number of things. So Amazon actually website, so the store, is using their service, this particular service, so machine learning, to be able to determine how many things people are buying and how many things we need to order for specific times of for the season, for example. And let's say you have a Christmas sale or Black Friday, which we recently had, and they know that particular phone, let's say Samsung Galaxy S7 Edge or whatever else we have out there right now, it's going to be a hot hit because everyone will buy it. They use this particular algorithm to determine how many of those they need to order in stock in order to be most profitable. Obviously, they don't want to overstock it because they're going to pay for the warehouse and they're going to be able to sell it, but they don't want to under-order it, which means they're going to sell out and not going to make profit. So they use this service, and it's awesome, which we're going to go through in more detail in the future. And you can actually teach the machine of different behaviors and patterns, and you can actually, use it to predict specific things. Obviously, you could even go as far as predicting the tomorrow lottery numbers. I'm pretty sure there are people out there trying to do that. I'm not sure if it's going to be as accurate and 100% because I'm sure there are projects and people used it before. But I'm giving you an example of what you could do. Just a little seed in your empty pot, so you can actually think of different scenarios and how you can use it. Another one, it's called QuickSight. It's a fast cloud power-based business intelligence service that makes it easy for all employees to build visualization, perform ad hoc analytics, and quickly get the business insight from the data. So basically, you can get files, you can get data sources and anything else, and you can build charts and some sort of BI intelligent systems that will actually visualize the data in some sort of way. So imagine a situation that you have an Excel spreadsheet, and in Excel spreadsheet you keep your sales, and every single day when the sales happens, you can keep adding them into the line, and in this case, we could actually say that that line is number of days, and that line is number of sales. And in this case, the quick site can actually go through your Excel, fetch all the rows that match in particular day, and show you on the visualize how many sales you made, and that's pretty much as a service. So I know you can do this in the Excel charts, and you can do the same thing. I gave you an idea more or less how it works, and you can also obtain the information from a databases. You can obtain from pretty much Salesforce. You can link it pretty much everywhere if you think about it. So it's actually awesome. It's currently recently it came out from beta, I think last week, and now it's fully GA, which means you can start testing it and have fun with it. So that's pretty much QuickSight. Let me hide this, and let's go to a last one. It's called Data Pipeline. What it is, it's used to extract, transform, and load data from other locations into AWS. You can schedule the activity and get alerts in case it fails. So basically, yes, you can leave your computer running 24/7 just to have access to your file on the NAS. That's great, but you cannot say that the computer will be running 24/7 because you might have a power loss, you might lose, I don't know, a hard drive might fail, or something might happen on the computer itself. In this case, you can use a data pipeline as a service itself that can fetch the data and actually transform, extract, and do lots of other things and put it into AWS itself. It's a very handy tool, and we'll discuss this more in the future. So we reached the enterprise applications. That particular section consists of workspaces, consists of work docs, and work mail. What it is basically a fully managed environment for you to use, where workspaces, work docs, and mail is basically the environment you work on. And I'm going to give you some ideas in the next slide. So, Amazon Work Docs. What it is basically, think of it as enterprise Dropbox, used to share all your documents with your colleagues. It creates a single, basically, Dropbox that you can share with all the friends and colleagues, and pretty much everyone can link to it, and you can use it as pretty much like a SharePoint, except it's a storage rather than the website itself. So yeah, that's pretty much what it is. Another one is called Workmail. It's Amazon's answer to Exchange. You can provide everyone in your company with the same email system and calendar. Now, we all know Exchange. We all know how big it is and how complex it is. And if you ever manage the Exchange, you know how pain on the bum it is. Especially once you reach a big size and you have multiple systems, multiple servers, and all you're trying to do is basically manage this. Amazon Workmail is basically a simplified version of Exchange. It's basically Exchange as a service, which is awesome because all you need to do is add the users, and that's the extent of your administrative tasks, which means the rest of the time you can sit at your desk and do absolutely nothing and say you're managing the work email server, which is absolutely great. Yes, there are other services, for example, like Office 365 you can use as well, but obviously that's not part of this particular session. I'm just giving you an idea of what Amazon Workmail is in compared to. Another one is called Workspaces. Workspaces is an enterprise application that gives you, as a standard, Windows desktop that you can control remotely. So think of it as remote desktop environment for all your work colleagues that you have. Let's say you have a company that is many different offices around the world, and all of those people want to use pretty much the same system, access the same desktops, and have pretty much the same policies around. What normally you would do is, yes, you can have a system administrator in every single of those places to manage that. You can do it remotely if you want, but you can actually use workspaces. And what it is, it's basically creating a Windows 2012 remote desktop session, and all of that can be linked, for example, with services like S3, or you can use other services that you can actually copy the data from and have access to, which means no matter the location of the user, they all feel like they're in the same office, yet they're scattered around the world. We use this quite a bit. It's pretty good. It does have limitations, which we will be able to talk about this in the next probably few sessions, but that's just more or less the overview for this one for now. Now, your favorite knowledge base. Let's go for it. Where does Route 53 get its name from? Route 53 is 53 is the port on the DNS it uses. From 53 available AWS routes, it does not have specific name significance. On average, the ping latency between AWS resources is 53 milliseconds. I can see the answers flowing. That's great. Keep it coming. Keep it coming. Okay, pretty much everyone answered A. Exactly. I only have one answer, C, which is it doesn't have specific significance. Yeah, you could potentially go for this answer. I understand why, but actually, if you ever work with the DNS, you know it's using port 53, which is the most famous port for that, and obviously that's the correct answer. So remember, Route 53 gets its name from a port it's actually using. Pretty much everyone got the response. Congratulations. Another question. Which service allows you to stream data into AWS? Is it A, Elastic MapReduce? Is it B, QuickSight? Is it C, Kinesis? Or is it D, Data Pipeline? That's a tricky. I see different answers. Interesting. Okay, I see lots of different answers. Okay. So the correct answer is C. Kinesis allows you to stream large amounts of data into AWS from mobile apps or sensors. So no worries if you answered wrong. That is absolutely fine. We are here to learn. We are here to discuss this. We are here to actually improve. And by the end of this session, you already know that the correct answer for this particular question is Kinesis. And by the end of the all of the sessions, you'll be able to answer this question on the exam and get your certification. So no worries about the wrong answers, because they're not really the wrong answers. We are all here to learn. That's absolutely great. Another question. Which of those is not an AWS enterprise application? Is it A, WorkDocs? Is it B, Workmail? Is it C, Work Server? Is it D, Workspaces? I can see the answers flowing. It looks like everyone is doing copy-paste, the same answer. It's absolutely amazing. Yes, it's C. Work Server is not part of the enterprise application. Everything else is. It's 100% guess correct. Now we're gonna go for mobile services. Let's skip that slide and go straight into it. So I'm gonna speed up a bit because we have about 20 minutes to finish this particular session, and I still have a few things to go. So I will try my best. Amazon Cognito, what it is and what it does. Basically saves mobile users' data into AWS. If you're ever working with the application deployment and you're ever using mobile as your application, basically a host, you probably will want to use Cognito because it allows you to it will allow you to stream all your data into AWS Cloud itself. Another one, mobile service. Mobile service analytics tracks and measures up in-app activity, which means if you have a mobile app, you'll be able to have analytics based on that. Imagine Google Analytics on the mobile in the AWS form. That's what it is. Now, Amazon Simple Notification Service, also known as SNS. What it does, it sends mobile notifications, emails, and SMS messaging based on different scenarios. So, for example, if you have a situation that you want to send user a specific, I don't know, maybe text message because they just sign up for your service, you can use Amazon SNS and provide with SNS the message as well as the mobile number, and it will do it for you. It can be fully automated. It can be linked with many other things, and in fact, lots of other service providers are using it as Yelp, Periscope, and Tinder. So another one, AWS Device Farm. What it is and what it does. It allows you to test all your applications on a bunch of different iOS and Android devices in the same time. What it means is you don't need to have hundreds of different mobiles on your desktop anymore to be able to test this. All you need to do is upload the application and click Run button, and it will run through every single possible scenario, and it will tell you which devices will have an issue. I don't have to tell you how important that is and how quick that is, because it allows you to actually exclude all of the possibilities, all of the issues, without actually having physical devices. It's absolutely awesome. Another one is called AWS Mobile Hub Builds. Allows you to test and monitor mobile apps. Basically, it's like a sandbox for you to start building your applications in one place and basically publish this as well. Another section we came now is called IoT. I remember we had a question about IoT, and we're gonna get to this in the class as well. I don't think we're gonna have a question on the exam about that, but it's good to know what IoT is and why we're gonna use it. So, IoT itself. AWS IoT is Internet of Things. It's a managed cloud platform that lets connected devices such as cars, light bulbs, sensors, and other things interact with the cloud. Now, recently there are lots of things like smart houses, like smart light bulbs, like smart, pretty much everything you can think of, it's pretty much smart now. IoT allows you to basically create different recipes, different scenarios, and based on that, control different devices and have a different behavior. It's kind of a little bit of future, and it's kind of a little bit of awesome, and you'll probably want to research this a little bit more, and you will see the possibilities of that are endless. Just to give you a rough idea, for example, you can have a light in the house connected to IoT, and you can specify if the sunset goes down, or if there's a sunset, for example, turn on the lights in my house, and it will do that. You can have another one saying, for example, if I'm away from home, turn on the lights. So when you leave the house, the lights will come on, and that's the thing. You can control devices from AWS IoT, because you can create those recipes and create those logical behaviors that you can apply to different devices. Now, another one is basically developer tools. We have code commit, we have a code deploy, and code pipeline. I'll go through them very quickly if I may. Code commit allows you to create AWS hosted version control for your code. It's basically like a version of a GitHub based on AWS. It is basically a GitHub, and allows you to basically pull from all of those places and deploy to and be stored in the S3. Another one. Through also AWS code deploy, you can get your code from code commit repository and deploy it to your EC2 instances, which means you can have multiple versions of your code, and using the code commit, you'll be able to deploy all the stuff directly to your servers. So it's a fully automated repository that you can use in elastic environment. Sorry. And the last but not least is a code pipeline. What code pipeline is, what AWS code pipeline is a continuous delivery service of fast and reliable application updates. Code pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. Now, that service on its own is what every single DevOps guy pretty much loves and wants to hear. It's the service that when you change the code, it redeploys this code on the new environment or on the current environment and changes everything for you, so it's instantly available if you want to. That means you don't need to ever spend hundreds of hours sitting and updating every single server in the rack just because you want to make sure that the data is exactly the same. In fact, doing that, quite likely you're going to skip through servers and quite likely you're going to have a different data within a few minutes because we're just humans and we make mistakes, especially after you've done this 99 times on 99 boxes, and this 100 will have a different code and suddenly nothing is the same. With the code pipeline, you'll be able to automate this and make it exactly the same every single time. So save time, save money. Knowledge check. Now, which service allows you to save mobile user data in an AWS cloud? Is it A, Cognito? Is it B, SNS? Is it C, Device Farm? Or is it D, Mobile Hub? Still waiting for a few answers. Okay, the answers are in, and the correct answer is A. I can see pretty much everyone answered A. That's great. Few people answered B and D, which can be confusing. Yes, device farm sounds like something you want to store the data, but in this particular case, we're using Cognito, which is exactly saving mobile user data in the AWS cloud. No worries if you answered wrong. Now you know the correct answer, so don't worry about that. Now, which AWS service is used as a code repository? Is it A, code deploy? Is it B, code commit? Is it C, code pipeline? Or is it D, Lambda? Still waiting for a few answers. Okay, the answers are in. The correct answer is B. Pretty much everyone answered B, and if you didn't, don't worry about it. All sounds pretty much the same. Again, now you know the correct answer, and feel free, if you're not sure, you can always feel free to go to all those documents and read it again and also watch all those videos, and you will understand why it's this particular answer. Now, AWS Management Console, and we have management tools. Here we have a multiple different sections. We have a CloudWatch, we have a CloudFormation, CloudTrail, and few others, which I'm going to go with you just about now. So, starting with the CloudWatch, enables monitoring of EC2 and other Amazon Cloud services, so you can get alerts when error occurs or when AWS service disconnects. Basically, it's a monitoring service that monitors every single resource on AWS. It's fully integrated with AWS. It monitors pretty much all the metrics of AWS. The reason why it's being deployed is because physically you have no access to your servers. Physically you don't know. You cannot log in. You can log into the box and check from the OS, but you have other metrics that you cannot. And AWS itself, especially CloudWatch, allows you to monitor every single metrics you can think of. Second, CloudFormation. CloudFormation allows you to set up a bunch of connected AWS services together. Basically, CloudFormation allows you to predefine resources that you want and put it in a code. So imagine a situation, I want to deploy a web server and a database, and I want this particular behavior or this particular pattern to happen multiple times because I want to deploy this everywhere in the world in the same way. What I will do is I will create a single CloudFormation template, And this particular template will specify, I want a web server that is EC2, I want a database that is RDS, I want this size, I want this number of megabytes of storage or gigabytes, I want many different things. And with this particular template, you can basically deploy that in every single region in exactly the same way. All you need to do is copy this template and copy, paste, launch, and you're going to have exactly the same environment in every single location. That's what CloudFormation is. We're going to know more about it in the following sessions. Next one, CloudTrail. CloudTrail audits users' activity on your AWS resources. Basically, every single action that you ever take, either via AWS Console or via the API, because AWS Console actually is a pretty interface that is using API anyway, is being logged. And you can enable this. By default, it's not enabled, but you can enable this particular service, CloudTrail itself, and it will log every single activity for every single resource that AWS is actually you launched. If you spin a new server, it will be logged. If you deleted the server, it will be logged. If you just logged on, it will be logged. So it's a very good point for auditing and seeing what actually went wrong. Maybe someone deleted something. You can go back to the log and you can see it. AWS config. Basically, AWS config keeps track of configuration management changes. Imagine a situation. You want your system or your environment to look in the way you designed that. And you have multiple people working with you, and all of them have access to your resource. You cannot spend all day long looking at people's hands and making sure that they are not changing anything. Hence, what you would do is deploy AWS config that remembers the configuration, and if anything changes, you will be the first person to know about it. OpsWorks. What OpsWorks is help to configure and manage operations using Chef. If you ever worked with deployment, quite likely most of you did, Chef is automated orchestration and automation tool that allows you to perform lots of different actions. And OpsWorks actually integrates it actually integrates with Chef and allows you to do specific actions. That's what I will say at this particular stage, because that's just overview. More will be to come. Another one is called service catalogs. Catalog gives you gives other AWS users in your group access to presets app that you've built. Now, basically, that's all you need to know. Catalog gives access to other users with the presets, and that's all I have to say at this stage. We're gonna know more about it in the next more detailed section. Now, trusted advisor. It's a very, very interesting concept that AWS did, and what it is automated services that identifies areas where you have where you're paying access for your AWS resources, something like, for example, AWS EC2 instances and a few others. It has 4 sections: cost optimizing, performance, security, and fault tolerance. If you think of AWS, you would think that all they want to do is make money, and to some degree it's true. But what they've done is, and how they want to be seen, is that they're trying to save you money, that you pay per hour, and then they don't want you to spin up those boxes for too long. And what AWS Trusted Advisor is a tool that you can run across whole account, and it will go through optimizing your account based on the cost, based on the performance, and maybe if you have security issues, it will go through that as well, and it will flag any potential issues. Just to give you an idea, you have developer box that you just spun up, and developer is working on it. That's great. And then developer finished working on it, and the box is still running. Guess what? You're still paying for it because you're paying per every single hour. If you run this Trusted Advisor, maybe weekly or monthly, it's up to you, it will be able to tell you, hey, this particular box seems that there's not much traffic to it, and I would actually recommend shutting it down to save money, and you can actually take action. Also, if you spin up the box that is way too big for what it's actually doing, and it's using maybe like 5% of CPU rather than 50, this particular tool will tell, hey, I actually noticed that this particular server is not being used much. I actually recommend scaling it down maybe a notch or 2, so making it smaller. This way you will be able to save money. And security as well. hey, I noticed you have a port open, which is pretty much open to the internet. Are you sure you really want to have your SSH or a remote desktop open? And we'll flag it straight away. It's a very good tool. I highly encourage to use it. Now, one of the last ones is security and identity. Okay, I'm gonna jump straight into the slides. Identity and access management, also known as IAM, allows you to set up additional users. You can generate new keys, set up policies, and everything else you can think of. Think of it as Active Directory. Think of it as any authentication that allows any user within your organization to log in to AWS resources. Now, you can use IAMs to create users. You can create groups. You can assign different permissions to different users or groups. You can have multi-factor authentication based on your policies, different things. That's just overview. All of that will to come. Another one, Amazon Inspector. What Amazon Inspector is, it installs agents on your EC2 instances and scans AWS setup to determine its security. Think of it as a security daemon that runs on all your instances, and if it detects some abnormal behavior, you'll be able to have report straight about this. Or if there's a specific breach because there's a specific port used, you'll be actually notified straight away. Not many people are using that because they have internal systems that they use, like Symantec or Sophos or whatever else you use. That's great. You can try to use this. It's pretty awesome, and it's fully integrated with AWS itself. Another one called AWS Cloud HSM service helps you to meet corporate, contractual, and regulation compliance requirements by securing, by actually introducing hardware security module into appliances for all the resources you have. So, for example, imagine you need to have additional security for your encryption keys. You need to have additional security for encryption and for data encryption. You quite likely will manage this through HSM. More about this in the future section. Now, next one, AWS Directory Service. It makes it easy to set up and run Microsoft Active Directory in the AWS cloud. Allows you to connect to AWS resources with existing on-prem Microsoft Active Directory. Basically, you will be able to extend your Active Directory into the AWS cloud. Yes, you can achieve exactly the same thing by having additional server running on the EC2, running additional AD, and you can link on-prem with this particular server, and that's maybe how you want to extend it. But there are a few services, like even RDS, that do not support AD itself because it's a limited service. And in order for you to have, let's say, a SQL Server authenticating against your AD, which lots of probably you do, then you will need to integrate it with AWS Directory Service that connects to your AD and links with RDS itself. That's just a rough idea. Another one, AWS Key Management Service, also known as KMS. It's a managed service that makes it easy for you to create and control encryption keys used to encrypt all your data. It's using basically hardware security modules to protect all of your security keys. You can actually upload your own keys that you have into AWS, and AWS will act like a storage for all your keys. And those keys can be used to encrypt specific data for your storage or for access to any other resource. You can also generate new keys with Amazon to achieve exactly the same. Another one is called Web Application Firewall. It blocks bad requests to CloudFront, protects your site. It's actually Amazon's attempt of blocking lots of unnecessary traffic towards your website, hence saving you money and maybe making it sure that your website's up and running, and preventing from something like a little bit of a DDoS. And I wouldn't say massive DDoS because it's probably not going to block it, because there's probably nothing that can, but it can do lots of protection like SQL injections, it's like sniffers, like scrapers. It can pretty much take care of that, block the traffic, and only users that are supposed to access your website are actually able to do so. And probably the last one on the list, yes, on the list is application services. I have a question regarding the web application firewall. Does it do intrusion detection? The answer is it kind of does, but it's simplified. Don't think of it as a fully blown intrusion detection system that is capable of learning different things. It's using simple patterns that are being pretty much added every single day. And if you want to read more about what it can do, I would actually go to AWS website, to AWS WAF, so WAF, and see what extent it can do. That's probably the best source of getting your information on that. So last batch of slides is about the application services. We have an application API gateway, which is a proxy, which basically which proxies your API, so you can throttle bad client traffic, test new versions, and process method more cleanly. So basically, you can write your own APIs and call APIs externally, and it will allow you to route your traffic to specific places. So basically, think of it as managed API service. Upstream. Upstream lets you deliver your Windows applications to any device. If you, for example, have multiple devices like mobile, tablet, and client, it can be Windows, Mac, or Linux, doesn't really matter. It will allow you to stream your apps directly into those devices. So if in your organization, for example, you have an app that you wrote and you want to push this towards everyone or even update, probably Upstream is the place to be and the service to use, because it will allow you to easily stream this automatically to all those devices. Cloud Search. What it is, it's Amazon's full text search service. That's pretty much all I want to say at this current stage. Allows you to search through any data based on your S3 or maybe any database. In this particular case, Amazon Dynamo. It's basically, think of it as a kind of almost an index of all your files on S3 and Dynamo. Elastic Transcoder. It's basically a service that allows you to transcode the media from a single format into the multiple formats to be delivered to multiple devices. I know it's being used a lot. Think of it as maybe a YouTube, although it's not really YouTube, but think of it like that. You upload your source, which can be recorded in, let's say, 4K, but then someone is watching the stream on the iPhone or on the tablet, and that particular tool or a device doesn't actually allow you to watch in the 4K. What it will do, it will stream down and compress the media to actually fit the particular device, and it does this on the fly. And all you need to pay is basically for time you use it, nothing else. Simple email service, also known as SES, allows you to send one or many emails, like marketing emails, password resets, and notifications. And basically, it's a mass email service that Amazon provides. That's pretty much it. Simple queue service, also known as SQS, is a hosted queue that integrates, increases the workflow between distributed components and applications that perform different tasks. Imagine a situation that you have different users, and those users have a lot of different tasks, and you have one server that can perform those tasks. Instead of all those users throwing all those requests to the server itself, you can actually put them in the queue, and then server fetches the last one, or actually the oldest one in the queue, for example, and processes them based on the order rather than everything at once. So that's basically it. Amazon Amazon uses simple workflow service, also known as SWF, in its warehouses. What it does, it basically allowing it's allowing to create a specific workflows that are most efficient. And imagine a situation that you have all those orders around the around the Amazon store, and all those orders consist of specific products, and those products are actually based on shelves across the data across the shelves in the storage, and it will allow to create a workflow that is the most efficient to get from A to B to C to D in the least amount of steps, to be able to fetch all those products into the basket to actually complete the order. So basically, that's pretty much it.